Hey there, today we'll be doing this question 547 number of provinces from Leetcode, and it is from the graph theory study plan. And all the other videos of the other days have been covered in the playlist. It will be coming in I button. Please do check that out. It will be helpful for you and to me as well. So coming on to the question, let's understand this question in a simpler manner. Otherwise it will get confusing if I just state it from here. So they have said that they will be giving a matrix, and I'll just draw the coordinates right here. And they have said that if city A and city B is connected to each other, so I'll just number this part as well. So we can see I and J, let's just say 1 comma 2 the value. So these two guys are connected. Why? Because it is having a value 1. Fine. So that means city A and city B are connected. So these 1, 2, 3 are being named as cities here. So 1 and 2 are connected. Fine. So they've also said that since there is a connection of 2 comma, that is 2 comma 2 and 2 comma 1, they are also connected. If you have not understood, not a problem, I'll just change the input parameter here and you'll get this part as well. So let's just ignore all the other ones and just consider for 2 comma 3. So I know that 2 comma 3 there is an edge between 2 comma 3, right? So I'll just draw an edge. Now they are saying that if there is an edge from 1 to 2, that means if I can travel from 1 to 2 and from 2 I can travel to 3, that means from 2 I can travel to 3. I can also travel from 1 to 3. And it is pretty obvious, right? Since there is an edge between 2 to 3, whatever the previous edges are of 2, I can travel to all the edges after that, right? So I'll just explain this part. That means if there is some edge connected afterwards to, right, whatever the previous edges of 2 are, these edges can travel to all the nodes or all the edges that is after 2, right? So this is the statement that was given to you in the problem statement, and they have said all the guys that are connected by somehow or other, they are known as a connected component. So if you see in the first video, that is in the day one number of island, this problem is exactly similar to this, just the statement have been changed in some manner. Otherwise they are exactly similar. So they have said that if we can reach from a particular node to some other node, that means it is connected. Fine. So this is a problem statement in simpler manner, and you have to return the number of connected components, or in other words, like from the day one that we did number of islands, so that is what you need to return. Okay, so it is just the similar one, just having the problem statement little bit changed, and they have given it in a matrix form. And yeah, that's it. So let's understand how do we do this part. So I've drawn another matrix right here for a better example, since the question statement had poor examples right there. So coming on to this example, I've already drawn the edges as well. So there is an edge between 1 to 4, 3 to 2, and 5 does not have any edge with any other edge. Fine. So all these numbers are considered as cities, okay? That is mentioned in the question. So we'll just consider this as edge for simplicity. So what can you do? So in number of islands question, if you have not referred to it, please do check it out. It will be coming in the link I button. Please do check that out. It will be helpful for you because it is exactly a subset of that question, or a subpart you could say, somewhat similar. So coming on to this part, we see that there are many edges, 1 to 4, 3 to 2, and all of these. So how can we do it? We can create an adjacency list at first. And why so? Because if we have an adjacency list, we'll be able to travel all the adjacent elements or all the adjacent nodes of a particular node. And why do I say that? Now let's just remove this matrix right here, since we do not have any use of it right now. So what will be the list looking like? I know from 1 there is an edge between 1 and 4. So I wrote this. Totally fine. Now from 4 I know there is an edge between 4 to 1 and to 3. Okay, and from 3 I can go to where and where I can go to 4 and I can go to 2. From 2 where I can go to 3 only. So, and 5 does not have any edge with anyone. This is a lunar edge. Okay, so what can we do? We know there was a given matrix right there. We can travel in that matrix, whatever the matrix is. We can travel in that matrix, and whenever we find a value 1, we'll start a DFS from there. Okay, so let's just say at the first position only I find a value 1. Now what do we have? So I said that we'll just start a DFS from there, right? So if we start a DFS from there, what all nodes can one visit? One can visit 4. So I'll just maintain a visited array which will say, okay, these nodes have been visited by whom? By 1. Fine. So I'll say, okay, 1 was visited, then again, one can go to where? One can go to 4. So 4 is also visited, and these ones are, mind you, visited. Okay, so these are all the visited nodes. Now from 4 I can go to somewhere. Fine, that is totally fine. And these things that I'm writing here is a plain DFS that we do. This is how a DFS, a simple DFS works, isn't it? If we are doing it in adjacency list. So from 4, where can I go? I can go to 1, but I see 1 has already been visited right here. Why shall I go there again? That would be a waste of time. So I will not go to 1. So 1 is not visited again. Now, can I go to 3? Yes, this is the first time I'll be visiting 3. So this is done again. Now from 3, I can go to where and where? I can go to 4. But 4 was visited. I do not visit this again. Can I go to 2? Yes, this is the newest node that we find. So I'll go to 2. Again, I'll come to 2. I see. From 2, where can we go? We can go to 3. But 3 has already been visited if you just check it right here. So I'll not visit 3 again. So I see, if I had a value right here and I started a DFS, all these guys would be visited. Fine. So this is forming a connected component. That means all these nodes are connected by somehow or the other. Fine. So after that, my visited array will be done. Now, when I come to the matrix cell, I'll just check that, okay, when I have an edge between 1 to 4, I'll somehow, when iterating, come to injth position where inj is 1 and 4, right? I'll come to this type of thing right here at some point of time. But I see it has already been visited by someone. That means it is already forming a component, that is a connected component with some other guy. Why shall I visit this again? But when I come to 5, the node 5, I will see that, okay, this guy 5 does not have any other neighbors with him. So what will I say? Okay, this guy is a loner guy and he's just forming a connected component with himself only. So that is why this right here is just forming a connected component with himself. And how many numbers of components are there? That means this one is 1 and this is another one. So there are at max 2 components that we have, right? So that is what you need to return, that is 2. Fine. So this is the whole whereabout about the question right there, and the explanation to how we are going to use the DFS. Now let's check the implementation part and you'll understand this better. So at first, we have created an adjacency list, and if you don't know adjacency list, please do refer to some other videos where they have explained adjacency list, because you'll be needing to know this concept beforehand. Okay, here we are creating an adjacency list, and we have created a visited array right here. Fine. After this is done, what do we do? So after we have created the adjacency list, what do? We just travel on our matrix that has been given to us in the question itself. Fine. When we are traveling, what do we find? We see that, have we visited that node ever? If we have not visited that node ever, we'll try to see if it is a city, because they have mentioned that there are values 1 and 0, and 1 means there is a city and 0 means there is no city right there. Fine. So we'll also check that, is it a city, and if we have not visited that city, what do? We start a DFS from there, and we increment our count by 1, and this is just maintaining how many components we have, and the number of times we are calling this DFS, that is what the count will be, and you'll be returning at the end of the day as your answer. Coming on to DFS, you see, this is a very easy question, a very small DFS that we wrote. We just said if that city or node has never been visited, or if it has been visited, what do? We'll just return from there if it has already been visited. But if it has not been visited, what do? We just mark it as present, or we just say that we have just visited it right now. After that, what do? We go to its adjacent cells, and that is what was explained in the DFS part right here while explaining. So we'll go to its adjacent and we'll just continue doing the DFS, which is a plain old DFS that we do. Fine. So this is the whole code walkthrough. Code link will be in the description as well. And if you did understand this question and the explanation, please do like and subscribe. And yeah, thank you for watching. But if you still have any doubt, please do ask me in the comment. I'll be replying to it as well.